Okay, so imagine, right, you're just chilling, watching like a movie on your phone, but the picture's so bright, so vibrant, it's almost like you're, right there in the action. And get this, even after like hours of watching, your battery's still going strong. Now that's the future that scientists are working towards. And they're getting closer thanks to this like huge breakthrough in the world of semiconductors. Now, I'm sure you know semiconductors, they're like the tiny engines that power all our electronics. They control the flow of electricity, which makes, well, everything work. But what if, and this is a big what if we could make them even better, like even more efficient, brighter, faster? Well, researchers have figured out how to make a new type of semiconductor, and it does something really cool. It makes electrons move in a spiral. Now, this might seem like a small change, but trust me, it could have massive, and I mean massive, implications for basically all electronics. So how does it work? Well, it all boils down to something called chirality. Chirality is basically is a fancy way of saying something has handedness, like your hands. Your left and right hands, they're mirror images, but you can't perfectly stack one on top of the other. And get this, chirality, it also exists at the molecular level, and it can affect how electrons move within a material. So these new semiconductors are designed with a specific chiral structure that forces electrons to travel in a spiral pathway. And here's where things get really wild. This spiraling motion, it causes the electrons to give off a special type of light. It's called circularly polarized light. Now you might be wondering, okay, so what? What's so special about circularly polarized light? Well, picture it like this. Regular light waves, they vibrate in all directions. But circularly polarized light, it vibrates in a corkscrew pattern, either clockwise or counterclockwise. And this unique property, it could completely change how our screens work. Like take OLED screens, for example. A lot of light from those screens is wasted because of how the filters work. But with circularly polarized light, we could potentially eliminate that waste, making our screens brighter and more energy efficient. Twice as bright, but uses half the battery. And honestly, we're just scratching the surface here. Being able to control electron movement at such a fundamental level, I mean, it could open up so many possibilities in electronics, it's almost mind-blowing. But hold on, because this discovery goes way beyond just like brighter screens, it could also totally transform things like spintronics and even quantum computing. Now, spintronics, that's all about harnessing the spin of electrons. It's an intrinsic property, kind of like their own tiny magnetic field. If we could control electron spin, we could potentially create computers that are incredibly fast and energy efficient. And you guessed it, this new type of chiral semiconductor could be the key to making spintronics a reality. And then there's quantum computing, which uses, well, the crazy principles of quantum mechanics to do calculations that are impossible for even today's most powerful computers. And guess what? Controlling the spin of electrons is like essential in quantum computing. And again, these chiral semiconductors could be absolutely vital in advancing this field. Okay, so we've been talking about spiraling electrons and circularly polarized light. It might sound, I don't know, kind of complicated, but what it all means, it's actually pretty huge. Like we could be looking at a complete change in how we design, how we build electronics. It's like, okay, think of it this way. For like forever, we've been building electronics with parts that are, well, they're basically symmetrical. But with chirality, we're bringing in this whole new level of control. It's like we just discovered a brand new set of building blocks, and they have these unique properties that let us build things, devices that, well, we could never build before. And, the coolest part, this whole area of research is moving so fast. Scientists, they've already built these new chiral semiconductors into OLED devices that actually work. They call them CP-OLEDs, which stands for circularly polarized OLEDs. And get this, these CP-OLEDs are breaking records. Like, they're crazy efficient, super bright, and have polarization levels that are better than anything we've ever seen. But here's the thing, this isn't just about displays. It's way bigger than that. These chiral semiconductors, they could totally change, like, everything. Solar cells, for example. We can make them way more efficient at taking sunlight and turning it into energy. Imagine if like every surface, buildings, clothes, everything was coated with these flexible solar panels made from these materials. We could be generating clean energy from the sun everywhere. And think about sensors. We could use these chiral semiconductors to build sensors that are so sensitive they could pick up on even the smallest changes in the environment. Like imagine monitoring air quality, finding tiny amounts of pollutants, or even, using them in medical devices to diagnose diseases super early. And the research, oh man, it doesn't stop there. Scientists, they're already trying to figure out how to build even more, I don't know, like sophisticated chiral semiconductors that can do even more. Like imagine materials that can just like change color whenever you want, or even switch between left and right-handed chirality just with a simple electrical signal.